For our last example today, we're going to use this table of characteristics of a binomial random variable to determine if our scenario describes a binomial random variable or not. So we'll just read through it first, and it's about tracking missiles with satellite imagery. The U.S. government has devoted considerable funding to missile defense research over the past 20 years. The latest development is the space-based infrared system, which uses satellite imagery to detect and track missiles. This comes from the journal Chance, Summer 2005 edition. The probability that an intruding object, such as a missile, will be detected on a flight track by SBIRS is 0.8. Consider a sample of 20 simulated tracks, each with an intruding object. Let X equal the number of these tracks on which SBIRS detects the object. So in order to determine that X is approximately a binomial random variable, we're going to check the characteristics of a binomial random variable. The first item says the experiment consists of n identical trials. So we can see clearly that we have a sample of 20 simulated tracks. So we've met that criterion. Number two, there are only two possible outcomes for each trial. So what we're actually testing or tracking is the number of tracks on which SBIRS detects the object. So either the object is detected or it is not detected. So we have satisfied number two. Number three, the probability of S remains the same from trial to trial. This probability is denoted by P, and the probability of F is determined by Q equals 1 minus P. So F represents failure, and that's found by taking 1 minus your probability of success. So we have a probability given here. It says the probability that an intruding object will be detected is 0.8. So if our p-value is 0.8, then we can actually calculate the probability of failure, 1 minus 0.8. So that would be 0.2. We have satisfied characteristic number 3. Number 4, the trials are independent, and it tells us in the narrative that we have 20 simulated tracks, each with an intruding object, and that SBIRS satellite imagery will detect and track missiles. And finally, the binomial random variable X is the number of successes in n trials. So our last statement says that X equals the number of tracks on which SBIRS detects the object. So we know that we've got our 20 trials, and X is going to be the number of these trials in which we detect an object. So we've met all 5 criteria. So we can go on to part B to answer a few questions about these missiles that are being tracked. Part B says give the values of P and N for the binomial distribution. So we've just talked about that. Our P value is the probability of success, or P of S, and that was given in the problem as 0.8. N represents the number of trials, and there were 20 observations. So that tells us that we need to use the table, the binomial probability table associated with an n value of 20, and then our probability of success 0.8 tells us that we're going to use column 0.8. So our next question, we're going to calculate the probability that X is equal to 15. So if it's exactly 15, then we're looking for row 15. Follow that across and double check that you have the right column and the right row. So we have 0.370, But remember, 0.370 includes row 15 and everything smaller. We don't want everything smaller included, only row 15. So we'll need to subtract everything that's below. So we're subtracting 0.196. So the probability x less or equal to 15 minus the probability of x less or equal to 14 means 0.37 minus 0.196 gives us the final answer, 0.174. In part D, we're looking for the probability that x is greater or equal to 15. Since it's greater, we're thinking 1 minus something. So that's the probability that SBIRS will detect the objects at least 15 tracks. So we're taking 1 minus the probability that x is less or equal to 14. So looking for that value, that's our 0.196. So 1 minus 0.196 leaves us 0.804. In our last question, we're going to find e of x and interpret the results. So remember, e of x is the expected value. Expected value is mu is equal to n times p. So the number of trials times the probability of success. And our number of trials is 20 trials, and our probability of success is 0.8. 20 times 0.8 gives us 16 is the expected value. So what this means in terms of our missile detection is that the average number of intruding objects detected in 20 trials is 16.